Hi viewers, and welcome to the channel, and welcome to the Understanding FreeCAD series. We're on lesson 3 and we're looking at building a piston and crankshaft assembly and animating that in one of the assembly workbenches. This lesson is made up of 4 parts. We're currently on part 3. Now in previous parts we built the piston head, crankshaft and connection rod using a master sketch and the part design. We're going to now take all those elements and assemble them in one of the assembly workbenches. Now this lesson may be a bit advanced if you're very first starting out with FreeCAD. So if you want to skip this one and move on to other lessons in this course, then please do so. We've got other lessons coming up in the very near future. So this is a weekly course. If you do want to tackle this, then you'll be assembling the model in the A2plus workbench, learning how to import parts and connect them together, dealing with certain issues that you may come across, learning how to use a master sketch inside an assembly, and learning how to constrain those parts together to see that assembly working as one. So let's have a look at this lesson and learn how these parts work together. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. So we have our crankshaft, piston head and connection rod. We're going to start building these into an assembly now. We're going to use the A2plus workbench. This is available from Tools Add-on Manager. Now there is 2 workbenches that I tend to use, and that's the A2plus and the Assembler 4. These are 2 different workbenches. They work in 2 different ways. We're going to be using the Assembler 4 in another tutorial regarding the same assembly in the future. So just to install it, just click on it and install, update selected, and you're ready to go. We're going to have a look at a bit of an issue with this piston head when we come to assembling, and we're going to use a different way of creating this hole to overcome the issue. Now if you think of this head and we look at it side on, so click on the left and we click on that edge of that hole, you can see how that hole is built. It actually goes in as a curve. Now with assemblies we need to have like for like edges if we're going to connect them. We're going to be using a circle and circle constraint for this circle here in the assembly. Let me show you over in the assembly workbench. So I've already got this installed. Let's go to A2plus and we're going to create a new file. So we do everything for a new file in assembly. I'm going to save it. And I've already got a piston assembly demo file there. I'm just going to save over the top of that. You just create your own file. So we're in the assembly here. We can add items into this assembly. I'm going to use the part workbench. I'm going to create 2 cylinders. And I'm going to convert both of these to an A2plus part. So I'm going to come over to the A2plus workbench. And we have to convert parts, because if I transform one of these parts side by side so we can see them both, and we'll convert this cylinder here to an A2plus part, you will notice something different between this cylinder and the A2plus cylinder. So we can see the original cylinder has been made invisible. Click on the cylinder, you can see we've got radius, height, etc., and angle. And if we click on this cylinder, the A2plus part, we've got something entirely different. We've got a fixed position, which we can change, and we've got a number of other options in here: source part, subassembly, etc. there. So these are 2 different parts. To change the position of this part, we can right click, transform, and move it around. To change the size of this part, we've got to go to the original and change the radius. That won't take effect until we use the update parts in assembly, like so. I'm just going to Control Z that to place it back to the original size. When we're assembling parts, we use different constraints. So for instance, these are 2 in line. I'm just going to move one of them. First of all, I need to make this one as an A2 part as well. You can see how that's gone back to the original position where it's been placed. So it's no point in transforming these until you've created them as A2+ parts. When we import files into this, they're automatically composed as an A2+ part, and we can move them in our assembly to wherever we want straight away. So these are some distance away. I'm going to transform this one. We can use this tool here to transform, and this just transforms us into position. Take note of the one that's in a fixed position. So we've got this one is fixed as false, and this one fixed as false. One of them has to be fixed. One or more of them has to be fixed in the assembly. I'm just going to take this edge and control click this edge here and use an axis constraint to bring those in line. You can see we could not move some parts. The highlighted parts were not moved. They are not constrained. Also over constrained changed to a fixed part. So the thing to look at, they are not constrained to a fixed part. Okay, that just to set the constraint, that constraint has been accepted. If we look in here, there's a constraint here. We can click on it, come up to the magnifying glass. That will show you what's been constrained. Click off. I'm going to set one of these as fixed now. So I set this one as true. We now need to resolve the constraint, resolve constraints with the Rubik's Cube. That brings that into constraint there. I can still move these. So for instance, I can move this one up and this one across and OK. But the minute I hit the Rubik's Cube, they all come into that constraint. So we've got the axis constraint there. If I use this tool here, move the part under all constraint, you'll see that I can move that up and down that axis, but I can't move it this way. So I'm moving that this way, but no lateral movement this way. And that's a constraint kicking in. So just click and that will release that. So that's that movement. So you click the part, use the movement and click on that and it will move. The other constraint we'll be using in here is the circle and circle constraint. So if you look at these circles, they are from the side like so. You can see they're straight circles. So we can take those and you can see the circle and circle constraint has appeared. Click on those, accept, and those are constrained now. If I try to rotate one of these, transform, and we're looking at the rotation, and this is important in animation like so. Okay, you can see those edges have been rotated, they're out of line. When I hit the solve, that will flip back around. So if I transform this one using the move tool, and we'll rotate that along this axis. Okay, hit the solve, you can see that rotated this way. And that's important when we start doing animations because we'll be using axis constraints along here. If I take this axis constraint off, delete that, and now rotate, so we've got no axis constraint, but we've got circle and circle constraints. Right click on the cylinder, transform, and rotate that this way. Hit OK and hit solve. You can see nothing was solved. But if we rotate that cylinder like so, hit OK and hit solve, then this will come back because we've got circle and circle constraint there. And same with this one. Right click, transform, and go this way because this one's fixed, this one's not fixed. So okay, what will happen, this will snap around. So fixed position of true, fixed position of false. This one will move, hit resolve, that snaps around to there. So these are the two constraints we'll be using. It's important that the profiles match. So if we come back to our piston, we can see this is not a straight profile. So when we import it into this assembly, we can do that now using the import, using the piston head, open that up, go down to piston head, import. I'll come to this in a minute, the import, and click on that. And though these are small, we can still use that edge there. So I've clicked on that edge, control click on this edge, and we can't make the constraint. But if I control click that one to remove it from our select list, this one is still selected, and control click this one, you can see we've got a circle and circle constraint because those are coplanar, those two. This isn't a coplanar surface there, neither is this, so they won't constrain properly. So we need to come in with this object and make this circle coplanar either on the inside or the outside. I'm going to do it on the inside because it will be hidden in here, and this is where our pin is connecting anyway. So let's change the position of this hole and make that planar face rather than a curved edge here. To do that, we're going to need to remove that hole and rebuild it. I'm going to hide the connection rod and the crankshaft because we don't need those anymore. Come into the piston head, come down to the fillet, and what I'm going to do is remove this hole, which is this pocket, bring back this pocket, so we need to go back to here. So everything after this action, so the fillet can go, let's bring back the pocket, sketch can go, which will kill this pocket will go, this datum plane, where's that sit? That sits in the middle, that held that sketch on there, so that can go as well. So we're back to the pocket 001 there. Make sure that the piston head body is active, double click it, and that makes it active, or right click, toggle active body, and then we're gonna create a datum plane along this edge. And the idea is to remove material from either side here. So create the datum plane and hit OK. And we're going to create a sketch upon this datum plane. So I'm in the part design, create a sketch on that datum plane. It's on the wrong side. It's flipped us over the other side, but that's okay. If we hit close and come down to the newly created sketch, which is sketch 009, we look at the map reverse on the data tab. Let's give ourselves a bit of space. Map reverse, just click on there and set that to true. And what will happen when going to the sketch, that'll be in the correct place. I want to take some material away to straighten off these edges here. So I'm going to create a rectangle across here. Let's place that in there. And we can use some constraints in here. We can use either bring in the edges, or we can use a length constraint across here. Just hit escape to bring the mouse pointer back. What I'm going to do is just move this into position, just have a look. I think I can get away with actually removing some material by having this tangent to this edge. Let's come over to the model and just hide that datum plane. Now I need to import an edge that's planar. So this edge here isn't planar. This edge is. I could use length constraints in here. But FreeCAD doesn't support tangency to planar surface constraints at the moment, non-planar surface constraints at the moment. So if this surface came in, if I selected this edge and I tried to make one of these lines tangent to this edge, it will come up with a B-spline unsupported. So we can't do that. So I'm just going to get rid of that circle there. Hit delete. And I'm going to bring in the planar surface, which is the bottom one, and just bring in that one there, like so. Let's pull that one in. Now I can do a tangency against that. Tangent to there. And also we can do this one as well, tangent. And these can increase in size, so what we need to know is the size of our circle. So if we come into our master sketch, bring that in, we can see the circle there, and we'll click on external geometry, bring that circle in. That will reflect that circle onto our sketch. Let's just hide the master sketch now. Now I need to just click and hit escape, click on the master sketch, hide that. So that's there, we can see that's sitting there. I was going to make a tangent against that, but that's a bad idea. So let's move these so we just get an idea of how big that hole is. So that's good. I'm pleased with that. And we'll click on this line and create a height against there. 17.58. We're going to make that 18. Trouble is, coming around this way, if we're looking at this from this way and we click on one of these, we don't know whether we're doing a height or length. So if we get the one constraint wrong, it will come up as length of 0 and go orange. So we know we've got the wrong constraint in there. So just click on it and just use the other constraint. So I'm going to use 20 in there. That removes that material there. We can OK that, come up to tasks, close, and we've got that in place. Making sure we select the sketch, we can pocket that now. And I'm going to go all the way through to the first face. So that'll bring me up to there. You can see this side, it differs from this side, so we're going to put the sketch upon here. Just OK that, and we'll come up to the master sketch, this one here, the clone, press the spacebar and bring this back. We're going to click on this side, and I'm going to create a sketch upon there for the hull. So that's in there, and we need to select this hull. So using the import geometry, click on the hull, that casts it onto that face. We can go over to the model, and obviously we need the mouse pointer back, so escape, master sketch, press the spacebar, get rid of that, and now we can create a circle upon there. So making sure we come in, alter constraints to that point, come out, and we can make it tangent to there. You can see the sketch has failed there, so I'm going to do that again. Just Control Z that and hit escape, and we've got our circle, which is fine. Let's click both of those and do an equality across there. Select two or more edges. Starting to become a bit annoying now, so what's going on there? Not quite sure why that's doing that. This one and this one. Can't do equals, we can't do tangency, so I'm going to bring this out and click on it and just do a diameter across there of 15. If I have problems, then we can do that. So that's good, so we've got that now. Hit tasks, hit close, and that circle is sitting there ready to pocket. Make sure the sketch is selected, and we'll go for the pocket. Make sure we go through all. So this isn't going through all of them at the moment, so just click on the symmetrical to plane, and that will pass it through both of those. And now when we hit OK, we've got the circle in the correct place. We can hit Control S now, and that's all saved, ready to go. So we're going to start assembling our model now. We want the master sketch available, so I'm going to click on the master sketch, press the spacebar, so that's available, hit Control S. So we've got all items there, because we're going to use the master sketch to place these items into 3D space, to align them very first to make sure they're in the right position. I've created a new file here called Piston Assembly Demo 2 and just saved it. So this is just a blank file I've just saved. It's important to save the file when we very first start. I'm going to come over to the A2plus workbench and I'm going to import those parts using this tool here, Add Shapes from External File. And click on the piston head and click Open. You can see the imported objects window appears. We've got a number of objects to select. Just check them all and click Import. So those I've all imported into our assembly. These will be mobile, some of them, so just click and drop them into different positions. The important one is the master sketch. This will get us in a position where we can start assembling this correctly. So this is just for placement. Come around to the front, you can see this is the same placement as what it was in our assembly when we very first started. It's important to click on the master sketch, so the piston head master sketch is selected there. Come down to data and make sure the fixed position property is set to true. Click all the other parts, this one, and set those fixed position to false. So we've got all fixed positions as false for each of the parts except for the master sketch. I'm going to use the move apart tool, so I'm going to select a part. So first of all, I'm going to move the connection rod out the way and zoom out. It's the same as right click transform, which is transforming that out the way. Okay. So this will be our placement to place these in 3D space. If you think about it, when we place stuff in assembly, they just come in any direction. So for instance, this will be the one that's placed correctly. So we don't want to transform or rotate this in any way. Our master sketch, these others could be in a different orientation or angle, like so. And we have to place these somewhere in 3D space to make sure they are aligned properly before we start constraining them. So the last thing we want to do is put them somewhere and start constraining to this item here and then try to move it into the correct position. It's not going to work. So this is where the master sketch comes in handy. We've got our master sketch here and we're going to use the create an axis constraints against this master sketch. We're trying to match like for like, so this circle in here, the one that's not the chamfer, we're going to place that edge, constrain it against this edge. Control click both edges, so click that one and that one, and use the axis constraint. Let's place that in there. Let's set that constraint. When I move this under rule of constraint, so with this tool here, move part under rule constraint, click it, and then click the part. Don't drag it, just click it, and then we can move that, and you'll notice that I haven't got any lateral movement there. Trouble is, it's at an angle. Well, we can solve that by taking this circle and this circle, which is the hole, and doing the same, doing an axis constraint. So we're only using axis constraints at the moment for placement. Set that, place it at an angle, use the move rule under part of constraint, and we can now move that, move up and down, and that's absolutely fine. We're going to do the same for every single element in here. So we're going to take this circle now, the camshaft, and look for a matching circle, which is this one, and do an axis constraint against those. Set that. Now that's there. That can move under rule constraint, so move part under rule constraint. That can move this way. We can't move in this direction, but it can, if we click on it and either do a right click transform and move this along this axis like so, okay, that, and we hit the Rubik's cube to solve constraints. You can see that's rotated around that way, and we don't want that. We want this aligned with the top here. Well, what we can do, if we look at the object, look at the parts we've got, well, we've got this circle and this circle. Control click both of those and use an axis constraint upon there. Set that. And now we can use the move tool. We can go for a rotate just to prove that it's working. That's going to rotate the wrong one. Let's rotate this one. OK, and hit solve constraint, and that solves that constraint there. Last of all, we're going to do the same with this one and use the internal circle and use the connection point there, and again an axis constraint. Set that, that's upside down, so we need to flip that around the right way. So I'm just going to rotate this around the right way. So using the move tool, and we'll rotate that around this way and move that up. Let's come around to the side. Let's move this one now. That moves in that line, which is good. So we've got all these positioned in the correct position. We can now start creating constraints against these to allow for movement. One thing I need is a second one of these. So let's import that now. So import from the same model. So import parts, piston head, open, and we need the crankshaft body. Import that. Bring this around, and we're going to do the same. This circle, this circle. I know they're pointing in the wrong direction, but we can create the axis constraint, and we use the flip direction to flip this around. Set that, and let's move that under rule constraint. And then use the same. So this circle, edge, control click this circle, and use the axis constraint along there and accept. So those are all aligned in space, ready to be assembled. I'm going to save that, and now we can move on to the assembly. The first thing we're going to need is the pins for these. And also we're going to need some rotation points, because at the moment, if I click on this crankshaft body and use the move tool, you can see the center of rotation is up here. This is going to be spinning along this axis. So to solve that, we're going to create a disc that has the center of rotation in the middle and use that to spin this assembly. Hit OK. So to create a pin, we're going to be using the part design workbench. Now you would think we use the part workbench, but there is a small bug. But using the part design, we should be okay. So if I come back into this assembly and come over to the part design workbench, I'm going to create a pin now. I'm going to create a sketch. We need a part body, so we're going to come into the model, make sure there's nothing selected, otherwise it will pull in one of these parts as a base part. Create a body, and I'm going to create a sketch, and I'm going to place it along this plane, the XZ plane, so you can see the XZ plane. So following everything that we've done. Okay, that. Can come over to the model, and I'm just going to hide everything in here. Perhaps not the master sketch, so I'm just going to keep that master sketch visible. So we'll click all of these and control click the master sketch, press the spacebar button. And that's the master sketch there, so we can see that hole there. But I want to place it on this point here. So we're going to create a circle, hit escape, and we know the size of this is 15. So we're going to click on that, set diameter as 15, close that, and now we need to pad that. Now I know our pad needs to be 80 millimeters, so that will span the connection rod to connect the piston head to that. So we've got that there. Just going to hide the piston head, get that out of the way, and this one. Now the first thing we need to do is convert this to an A2 part. So come out to the A2 part workbench, A2plus workbench, click on that, and you can see this icon here. Convert a part, create another workbench to a fully functioning A2 part. Also available on A2 plus, convert a part to A2 plus part. That's actually disappeared at the moment, and that is because, can't actually see that. If we come into the body, have a look at the body, we've got the pad there. So the pad was selected when we did this. Let's just delete that new object there. This time I'm going to click on the body, come in, let's just make that pad visible so we can see it again. This time I'm going to click on the body and then convert it. So that's converted now, it's become invisible, that body, and we've got that body there. I'm just going to rename that to pin body. This pin will attach the piston head to the connection rod. Now we have problems with this. That's actually intersecting that at the moment. It's not under rule of constraint. So we're going to place this circle against this circle. Control click those two. Circle and circle constraints there. So circle axis constraint. Don't want the axis constraint, we want the circle and circle. And let's set that constraint. So that's connected there. I've forgotten to offset that, so I can come into that pin body, open that up, double click the constraint, and just move this over and change this offset. So -5, let's make it -45. Let's have a look, see what that is. So -35 there, and set that. So that's sitting inside there. We can now align that pin with the inside of here. So that pin, we can go this side, control click that side, and now we've got the circle and circle constraint, which is the right constraint that we want. So these circular edges are now compatible and do a circle and circle constraint. And we need to create some offset in here. So let's just create a bit of offset. There we go. So that's in there. Set that. And because these are all on the same plane, determined by our master sketch, which is this one, everything's okay, so we don't get any constraint problems. We'll disable the master sketch constraints at a later date. This is just for placement. So we've got that placed. Our next one is to place the crankshaft body. And again, we can come around, and I want to circle and circle constraint with this one and this one, and use the circle and circle. Set that constraint. It's the only constraint we need, so circle allows this to slip around and rotate around there. Bring back the other crankshaft. There it is, and use the same. So click on that circle there, and we want the internal circle in here, not the chamfered circle. Managed to get hold of the chamfer circle. Let's do that again. So internal circle and this one. Control click both of those, and circle constraint. Set those. So those are connected up like so. And now we're going to make the rotation points. So those are going to be the discs that are going to connect up to here. We're going to come back over to the part design. Click on model, make sure there's nothing selected. Let's just shrink that down. And create a body. Create a sketch. And we're going to be placed along the same plane, so the XZ plane, that one there. Okay, that, and I'm going to come into the model because I want it in this center point here. I'm just going to hide everything. Oops, shouldn't have done that. Let's go back to that. Press the wrong button, so bear with me. So click on all those and press the space bar, so hide in those. And that pin body. Let's come back into our sketch and create the rotation point. So I'm going to use a circle, connect it to that center point, bring this out. I believe this was 15 millimeters. So this will connect the crankshaft to a fixed position so we can actually rotate it. So create a circle, create a diameter on that circle, 50 millimeters. Okay, that, close that, and we'll pad that up to about 10 mil. That's fine. Let's bring back the items. Actually, let's keep them hidden. Click on the body, come over to the A2plus and convert that and rename it. So we've converted the body's selected, it's converted fine. Rename that to pivot body. So if I click on that body and do a transform, then when we rotate that, that's going to rotate around the center. We're just going to check that before we start. There we go, that's fine. So center rotation is absolutely fine with that because we used the center of the sketch. And now we're going to bring back the crankshaft. And what I'm going to do is come around and I'm going to click on that circle. Make sure nothing's selected. Click on that circle. Control click this circle and use the circle and circle constraint. Set that. We're going to create a copy of that pivot body. Copy. Right click. Paste. So we've got that second pivot point there. Right click, transform. Move this over this way. Okay, that. And we're looking for the other crankshaft. So come up this crankshaft, bring that into existence. Let's actually just hide that and transfer that body further over. Transform. Move this right out of the way. There we go. Okay, that. Bring back the crankshaft. Come in, control click the edge. First click the edge, make sure nothing's selected. Control click the edge. And this edge. And do the circle to circle constraint there. And set that. So we've got the pivot points in now. Piston head, the master sketch, and the piston rod. And also the pin. Where's the pin gone? There's the pin as well. So those are all in position. Just going to save that. At the moment, if I try to use the move apart under constraint, then we move in the whole lot. So we can see those are all in access with this. None of these parts should be fixed. So we can just go through the parts and make sure that none of them are fixed. So fixed position on all of them is false, including the pin. Yep, they're all false. So what we need to do now is convert this to a simulation. We can see everything is sitting nicely. We've got clearance. Everything is ready to go. So we've created the assembly. We've aligned the parts using the master sketch. So all the alignments here. And we've constrained our parts together to form the full assembly. Just want to go over the reasons why we've done this. So why we've used the master sketch to align our parts. At the moment, if we go over to the A2plus workbench, we have got constraints that only allow us to move back and forth against this master sketch because of the axis constraints in here. The reason why we've done that is because we can remove these axis constraints or disable them. It's as simple as clicking on one axis constraint and pressing the spacebar, and that will disable that axis constraint. By hiding that axis constraint, it also disables it. So if I shift select all of these, by clicking on one, pressing down shift on the keyboard and selecting the last one and press the spacebar, so all those are disabled, what will happen is if I start moving this, you'll see that the model is moving. Let's just zoom out a bit, and you can see that things are starting to happen. Things are starting to simulate. We haven't anchored any of those points, so what we'll probably get is a constraint problem. There we go. So we haven't got a fixed part at the moment. But if one of these parts was fixed, then that will start emulating. Now, how do I reset this back to the position that I was before? Well, I could try to painstakingly take parts of this and try to move this back up, and well, I've got it part of the way, but I've now got to bring this piston head over. Well, when we've got the master sketch and we've got a reference to align it, we can just shift click what we've disabled, press the spacebar to re-enable it, and then use the Rubik's Cube, and we're back in position. So we've got that back there, and because those constraints are active, then we can align this to wherever we want using this as our base alignment. So this makes life so much more easier when we get ourselves into a position that we want to reset and bring this back to the position that we was before. We're going to move on to simulating this piece now with the constraints, and then writing a piece of code to script the animation. So at the moment we've got these constraints here. We're going to disable these constraints, so shift clicking them all, press the spacebar. So that's on the piston master sketch. Now we're going to come down and select our point of rotation, which is this disc here. Let's have a look what it's selected. So this pivot body here. Open this up. And we can see we've got a constraint in here which constrains the pivot body to the crankshaft. And if I press the little red magnifying glass here, which highlights both the parts under constraint, we can see there's a circle there. And I can do a bit of transformation, so let's click off to bring that back, click on that and use the move tool, bring this out and hit OK. Click on the pivot body again and then use that constraint there, click on that constraint, use the glass, highlight both parts which are related to selected constraint, and you can see that constraint is there, those green circles. So that shows you what's under constraint. We've got no fixed parts at the moment. So our fixed part is this one, which we've disabled all the constraints on. So the fixed position here. This means this is anchored in space. And this is the reason why when we move this, then it's flowing freely in space, and we get the error message when we click off because we haven't got a fixed part. Just going to hit Control Z that to bring that back. I've got this separated at the moment, so I'm going to click on this part here. We moved it, if I enable these back like so, so the piston head is our fixed part, these constraints are now enabled and hit the Rubik's Cube, that will bring that back. Let's just disable those again, pressing spacebar, and put that back to the position where it was before by using the move tool. Move tool, bring this out. Okay, now we can't solve it because there's no fixed position part in this assembly. I'm going to fix that position now, so I'm going to click on it. Fixed position is false, set this to true. So you can have multiple fixed positions in your assembly. Now when we solve this, that has solved. If I use the remove a part under constraint now and start to move this, you can see parts of it are moving. So we've got some problems at the moment because we want to keep this crankshaft and this crankshaft in line with each other. So to do that, we can use an axis constraint, finding a line that is shared in the same axis as both these parts, and because they're the same parts, then we're looking along here. We don't want to use this line and this line because it will flip it around the wrong way. We're looking at parts that are opposite each other, so this line and this line, if we line those two, then we should be absolutely fine. So using the axis constraint along those two and accept that, we can see that's brought that in back into line there. So now when we start emulating this, things will start moving. So you can see that's moving around now, and our piston head is moving and everything else is moving. But I want to set this back to this position here, and to do that I can make sure this part is fixed as false, and that will bring all this back. But considering I've fixed this when it's in line with here, we may not need to actually do that. So if I set this as fixed as back to true, and all these are axis constraints, so it doesn't matter whereabouts along this line this sits, it's still in line with this part. If I press the spacebar to enable those and do the solve, then that brings that back into position. So now we just need to disable these, and then we can do our simulation again if I want to pull this back around and do our simulation. So we've got a fixed part that's already in line with our master sketch, this one here. Obviously if this fixed part was somewhere else, let me just move that over here and hit OK. This is fixed, so when we resolve that constraint, if we try to bring these back, because that is no longer in line with this circle, and we try to solve, it will try to rip this apart. So we've got a constraint over here, so it's trying to constrain to here in axis, and this is fixed, so we have problems there. So if I set this to false, so I'm fixing the position of this to false, now I use that, that's fine. Now we can set this fixed position to true, and then disable constraints there, and we start moving this to there. We've got two fixed positions, we've got this fixed position and this fixed position, and when I enable these like so and hit the solve, then we're absolutely fine. So let's pull that back into position because those two are along the same axis. So that's the reason why we've added this. It gets us back to a starting position quite easily without trying to fiddle about with the angle and the placement of these. So we've basically got our simulation at the moment. So let's just disable those. We have our fixed position point here. We have our constraints disabled and we can move this under simulation. When we move this, what you'll see is you can see that the piston head is moving laterally, which we don't want. We want to keep that in line. So we bring this up here. You can see that's off to the right. We need to keep this piston head basically over here so it's dead centered. I'm just going to bring those constraints back, press the spacebar and solve that to reset it. And you can see how this master sketch is coming in handy now. I'm just going to press the spacebar again. So I want to create something that's going to allow me to keep this in the upright position. For that, I'm going to create a ring around here, the same diameter of this. I am going to use the part workbench for doing this. We're going to use this tube. And I've looked back at the original problems with the part workbench at this moment of speaking. It's probably resolved in the future, and tubes should be fine. If I had a problem, I would use this in the part design, create the tube in the part design, but with the part workbench, we should be absolutely fine. So create a tube. We know this diameter is 80. So we come over and we're looking at radius here. So let's get this right. So inner radius is 40 millimeters and outer radius is something like 42. So what we're doing, we're just creating a small ring. And we'll go for height. Well, 10's fine. Creating a small ring. Where's that put that? So the idea is this ring here, if I transform it over, well, first of all, I've got to create it as a A2+ part, is this will sit in a fixed position above this, somewhere up here, and it will keep the axis locked between those two. So we've got fixed position ring sitting at the top, keeps the axis locked, and also that will allow us to hide this ring in our animations and see that moving up and down with a fixed position. We could also use this as part of the engine to allow us to move up and down that circle. So we've got this here, this ring, and now we're going to come over to the A2+ workbench and convert that. So we must click on the tube and use the convert a part, A2+, convert a part to an A2+ part. So we've got that tube there. Now we can click on that. The original tube has disappeared. Right click, transform, and we'll transform that not right by the side, but we're just going to have it floating just above it. We're going to create an axis constraint now. So I'm going to use the circle edge, so this circle edge here against this circle edge. Control click both of those. And then come up to the axis constraint and set that. So that's there. I'm going to place this a bit further up, so we'll just move that up. And remembering this is in line, so if I push it over to the side, press solve, that's going to bring that back into position like so. We now click on this, set the fixed position to true, and now when we emulate the simulation, or simulate, and move this, you can see that piston head, the movement is moving in line. We'll just do this slowly, and you can see how that moves in line with that head. So now we've got the head positioned perfectly, and that was a much easier job than what you very first thought, to have that in position. What we can do is click on that and press the space bar and hide that ring, and now we've got that tube hidden. It doesn't disable the constraint because it's still visible, the constraint is still visible, and when we move that now, you'll see that still stays in line. So we've got a fully working simulation of a crankshaft. We'll now go on to animating this, because we need to spin one of these discs to allow this to animate, and that will be our next task. In our final part of this lesson, part 4, we'll be taking what we've done and animating it using a Python script. So we're going to use a script to drive the animation to actually rotate one of those parts to allow the whole system to work as one. Again, this is more of an intermediate/advanced lesson, but it's divided into the separate steps, so you can miss that lesson if you so desire. If that lesson isn't already up on my channel, it will be up in the next coming days. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a Ko-fi site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. Thanks a lot for watching and subscribing, and I'll see you again soon.